guys! You asked me so many times to do a video on soy, so finally, here we go. Actually, it won't be just one video because it's such a big topic. For this reason, I will do several videos, and I will start with scary soy articles. In the video today, I want to speak about all the scary articles you find on the internet about soy and tell you how to read them properly. How can you distinguish complete bullshit from something that is true? As an example, here's an article on soy and thyroid function. It claims that soy milk will actually ruin your thyroid. The funny thing is, this article is not only about thyroid. Actually, it speaks mostly about different issues that are associated with soy, or people kind of bring them into connection with soy. And to be honest, I think the author of this article didn't really have idea what he or she is writing about, and I will explain you why in this video. The first thing is, when I look at the claims, they aren't referenced. So usually if you make a statement like soy is bad, you have to put a reference to a research paper behind it, or below the article, or link it to the article, so the readers can see where does this information come from. And in this article, the statements like here, for example, that soybeans have hemagglutinin that actually can mess up with your blood, it isn't referenced. If I have a look at the end of the article, there are actually references to 2 books. But I have a pretty big problem with references to books, because as you have probably seen already in my Starch solution discussion video, if you haven't seen it yet, I will put the link in the description down below. And books, lots of statements can be made, but most people don't really prove if the statements are true. So the statements that were, for example, in the Starch solution weren't supported by the research papers this book was citing. And I think there is also the danger that it might be the same with these books. For example, if you look at this issue that hemagglutinin messes up with your blood and look up the research, then you will see that actually this compound is destroyed when you cook beans after 15 minutes. So this paper is on kidney beans, but in general legumes contain these compounds, and they can be destroyed by heating. So there's absolutely no problem with this topic, because you usually eat cooked food, usually eat cooked soy products. So if you eat raw soybeans or just soaked and not cooked, you can really get some issues. And I don't even think that it will go so far that you will get some issues with your blood coagulation. No, I think you will just get really sick if you eat uncooked beans, so that you will just vomit and have diarrhea, so it won't even get into your blood. So if I don't like books as references, what references do I suggest, or what references do I look for? Well, usually that are references to peer-reviewed research articles. So that are articles from research journals, and here the important thing is peer-reviewed. Peer-reviewed means that when I, as a scientist, write an article or have done some research and I think I have done something super amazing, discovered a great new thing, I write it up as an article and send it to the journal and tell them, look at this, I have discovered something that is groundbreaking, totally amazing. And then this journal have experts in this field, and then this journal passes my article on to these experts. They read the article and give their feedback. Either if I'm totally mistaken, if I've written down the total bullshit, then the reviewers will say, no, it's total bullshit. She has no idea, don't publish this paper. And they will send my article back and say, okay, that's bullshit. But even if it's good, most reviewers do some corrections. So they're experts in this field, so they read it really critically and say, okay, now you have to improve this, maybe go back and do more experiments just really to prove your point. And if there's no peer review in this journal, which you can actually see if you go to the journal homepage and go to the About the Journal, it should be written there that it is peer reviewed. And if there's no peer review in this journal, then everyone can just submit like articles on topics they've just written up. It's like writing an article on the internet or for a magazine and asking to publish it. So for this reason, what I look for behind each statement should be a reference to an article from a peer-reviewed journal. Another thing I look for when I check out the references is if this research study that is cited or that have found that soy is bad was conducted in humans. Lots and lots of studies that have shown really scary things have been conducted on animals, for example, mice. And the problem here is mice, or in general animals, have different metabolisms than humans because we aren't mice. So what applies to an animal doesn't necessarily apply to a human. So for this reason, I usually look the research studies up that were conducted in humans. And another thing about animal research is that often mice are fed such an insane amount of the testing substance, like, I don't know, 75% soy isolate, that it isn't realistic in real life conditions, because I don't really think someone's diet consists of 75% soy protein powder, because it just, it's not realistic, it just doesn't make any sense. So that's what I check as well. So what was the experimental condition and does it make sense in real life settings? Another type of research studies that can be performed, that is also sometimes cited, are studies on cells. They are even one step lower under the animal studies. So they basically take cells, put them in a petri dish, put some stuff on top and see how the cells behave. If something shows an effect on cells in a petri dish, it doesn't mean that it will show the same effect on the human body, because maybe if we eat the substance, it will be excreted, maybe it won't be absorbed, maybe it will be detoxified before it even gets to our cells. And the third type of studies that are even lower, the cell studies, are in vitro studies. So they take an isolated compound, for example, a receptor or protein from the body, and put it in a reagent tube and put different substances on top. For example, like this phytoestrogens from soy. And actually there was a claim in this article about phytoestrogens as well, and that they are kind of a dangerous compound that is found in soy. But usually most of the studies, or many of the studies that showed kind of dangerous effects, were performed in an in vitro tube. And now I want to explain you why in vitro studies can give just some clues what might happen, but you shouldn't really look at the studies if you evaluate research. The in vitro studies have found that some compounds that are present in soy and have a similar structure to estrogen, so basically the hormone we have in our bodies, can also bind to estrogen receptors. And what these in vitro studies have done, they've taken these receptors and put them in a reagent tube and put then these soy estrogens on top and see, okay, it binds, so probably soy is bad. And now I'm going to explain you why it doesn't work in real life settings. Imagine I'm the estrogen receptor and I have a high affinity to estrogen, to this hormone, so I really like it. So let's imagine this estrogen, this hormone, is peanut butter, because I really love peanut butter. So if I'm sitting somewhere in the human body and the hormone, so peanut butter, floats around, then I just grab it and hold it and eat it. But if they take me now out of the human body and put me into a reagent tube and make some other food floating around I don't like that much, but I still can eat, for me it would be probably potatoes. It's not like I hate potatoes, but I would never come with the idea to buy potatoes for myself. If they're somewhere else and I have no other choice than eating potatoes, I would probably eat potatoes, but I would never buy potatoes myself because I don't like them that much. And let's imagine potatoes are also like food, all this is like similar substances you get from soy. So if someone puts me isolated in a reagent tube and puts potatoes in, I would probably eat them, because otherwise I would starve, because I'm just super bored sitting somewhere in isolation in a reagent tube, not having anything to do, whatever. I would just eat the potatoes. But now if you transfer the entire system back to the human body, whereas also peanut butter, the real estrogen that competes with the potatoes, and I have the choice, then I would prefer peanut butter. So the same is in our bodies. The natural estrogen, so the one we have in our bodies, have much higher affinity to this receptor than the compounds that are similar to estrogen that are found in soy. So if both is in the bloodstream, then the receptor would of course prefer the natural estrogen and not the soy similar estrogen compound. For this reason, you can't really transfer these scary in vitro studies to what happens in vivo. Another point in this article is that anti-nutrients that are found in soy can mess up the menstrual cycle. The interesting thing about it is that if something would mess up the menstrual cycle in women, that would be this estrogen similar compounds I've just talked about before and not the anti-nutrients. Anti-nutrients that are other compounds that are present in soy products or in soy in general that can actually bind minerals like calcium, zinc, and prevent them from absorption into our body. So basically, there's also this claim if someone eats too much soy products, that this person can become nutrient deficient just because all these anti-nutrients present in soy bind all the nutrients we need in our bodies, and so we excrete them, so we become nutrient deficient if we eat soy. That's why I mentioned in this video before that I think the person who actually wrote this article has no idea about the topic soy. The person probably just read this book that maybe cited some references and kind of in a weird context. Maybe this person just didn't even understand what is written in the book and just put some weird claims that were collected from the book into this article. Because if something would influence the menstrual cycle, that wouldn't be the anti-nutrients. This would be this estrogen similar compounds found in soy. And actually there was research on this topic. And indeed, one meta-analysis found that consumption of soy products can increase the menstrual cycle of women by about 1 day. So the menstrual cycle gets longer. But there are two interesting points. First of all, when this meta-analysis excluded all the research that might have been biased, then they have found no effect of soy product consumption on menstrual cycle. But even if we assume that this biased research have shown the truth and soy products increase the length of menstrual cycle, then it would be actually a good thing. Because the length of menstrual cycle, so how long it is, was associated with a reduced risk for breast cancer. So the longer menstrual cycle is, the lower the risk to get breast cancer. That was one of the suggestions researchers made. So this point about anti-nutrients in soy milk and how they mess up the menstrual cycle is doubly wrong. So first of all, they've taken the wrong compounds, so that aren't anti-nutrients. And secondly, even if it is the case, it will be actually a benefit. So what about these anti-nutrients now? Do they really make us nutrient deficient? And about these estrogen-like compounds in soy, do they have any effect on our hormonal levels? Well, I will discuss these points in my future videos. So stay tuned, subscribe to my channel if you haven't yet, just to make sure that you don't miss them. And if you like my videos, I would really appreciate it if you would share it with your soy scared friends. Thanks a lot for watching and see you very soon.